Okay, so as we talked about on Monday, we're looking at four quality management systems in this class: Lean Manufacturing, Six Sigma, ISO 9000, and the Malcolm Baldrige National Quality Award. And so today we're specifically going to be talking about Lean Six Sigma. So Lean Six Sigma is practically a perfect process. So we're are trying to manage our processes to be practically perfect. It's is a little recursive, little reminder here about where the Six Sigma comes from. So it's six standard deviations from the mean, from the top and from the bottom. So there's a 12. Um, yeah, there's a 12 sigma spread when we're looking at uh, using those as basically as our control limits for um, managing for quality. So it's basically virtually everything will be falling within that process, and we'll be looking at pretty much the whole process per million rather than say per hundred or per thousand. So the difference between Lean and Six Sigma, there is quite a bit of a difference. Together, Lean Six Sigma is a set of methods and tools that help customers create a competitive advantage by becoming faster, better, and cheaper than their competition. Lean part of it helps companies cut the time it takes to meet customer demands. So it's lean really is literally like that. You know, like you're losing weight. You're losing the stuff that's holding you back in order so you can increase throughput. Six Sigma helps find and fix the mistakes, errors, and defects involved in every aspect of delivering what the customer wants. And it's kind of a simple analogy, but I think I said this before in the classes. How I see Lean Six Sigma is that, lean, if you lean a process, say if you wanted to use your room, for the cleanliness of your room, the lean would clean the room, and then Six Sigma will prevent the room from ever becoming dirty again. So that's where you start, figuring you don't throw your socks on the floor. You have a regiment, of cleanliness and cleaning up, and so together they're the best of both worlds apart. I've seen people use lean before, just do lean, and they don't have the buy-in, and they get excited, they get on the bandwagon, and then it's good for 1 or 2 months, or even potentially a little longer than that. But then all of a sudden, people just go resort back to their old ways. It takes a dedicated mindset in order to maintain a Lean Six Sigma mentality in your workplace. Um, but once you do that, and once you're steeped in that, yes, we might have hiccups along the way, but everybody is following the same methodology in order to find defects, errors, and the mistakes. What I like about Six Sigma that is quantifiable and it's data driven. When you do something for an improvement, it's proven by data and quantifiable means. We use statistics to gauge improvements. We seek to eliminate defects and variation in process systems. It's a definition of conformance is a near perfect perfection in systems. So when we're trying to manage for quality, we're trying to achieve, conformance. It's nice to have a bar that's near perfection. A typical Six Sigma breakthrough project reduces costs by at least 40%, and delivers big, hairy, audacious goals, the BHAGs. And when you'll see in the Ford's Six Sigma um, handout, and in the industry, when you're going after a Lean Six Sigma project, you're looking at a pretty intense return. So they might not accept Lean Six Sigma project until it can achieve $250,000 in improvements or an opportunity. So it's quite a bit of improvement, and there's quite a bit of money coming in that you're saving or that you're getting that wasn't there before. And Lean Six Sigma is really customer centric. Everything revolves around the customer. As you heard me say, the voice of the customer 1,000 times in this class. The voice of the customer drives Lean Six Sigma. So following Mary Poppins, nearly perfect in every way. Six Sigma can be defined in several ways. It's a ways of measuring processes, a goal of near perfection, represented by 3.4 defects per million opportunities, or the DPMO. It's an approach to changing the culture of an organization. And most accurately, though, Six Sigma is defined as a broad and comprehensive system for building and sustaining business performance, success, and leadership. The Six Sigma measurement, remember, the higher we go, the less defects we have per million, and the higher our yield. So if we look at the Six Sigma rating at 3.4 defects per million opportunities, we have a near perfect yield. So we're only losing around 3.4 there per million opportunities on the Six Sigma. Five Sigma, 233, still pretty good, 99.77. So you can see this is our goal, is to go higher to the Six Sigma range. Okay, so why should we strive for Six Sigma? If electricity worked at 4 Sigma, we can expect no lights for about 1 hour a week. At 6 Sigma, there's no lights about 2 seconds a week. So you can see there that 1 hour a week would be totally unacceptable for us as Americans. And at 6 Sigma, you're looking at 2 seconds a week, a little blurb. For every 300,000 letters delivered, with 4 Sigma, you get 3,000 missed deliveries, and with 6 Sigma, you only get 1 missed delivery. At a 500,000 computer restarts, at 4 Sigma, you're getting 100 crashes, and with 6 Sigma, you're getting 2 crashes. At 500 years of month-end clothings with 99% or 4%, you get 4 Sigma, you get 60 months when not balanced, and with 6 Sigma, 0.118 months when not balanced. And at 500 surgical procedures, at 4 Sigma, you get 4 dead people, and at 6 Sigma, you get 0 dead people. So for every week of television broadcasting with 4 Sigma, you get 1.6 hours of dead air. And with 6 Sigma, you get 1.8 hours or 1.8 seconds of dead air. You can see there that, and this is why Six Sigma is used extensively in the medical field. It's because they're trying to eliminate the defects, which can eventually kill people. So you can see the difference there between the 4 Sigma and the 6 Sigma. So that's why we're striving for a higher Sigma. A bit of history on this. I'm not going to go over too much on this, but just want to kind of give you an idea. So when you ever heard of quality circles, that came from the TPS, the Toyota Production System. And what they did is they had a steady group of 10 or few employees, and that's the precursor to those Kaizen blitzes and the rapid improvement events, or rapid improvement REIs, rapid improvement events. So they use this. What they do is they have a problem. They get a bunch of people together and cross-disciplinary, and they look at the problem and they solve it. And that's where the quality circles came about. And that was around just the beginning of the late 70s, early 80s. The statistical process control, that was taking Deming's and Duran's method of using statistics to manage variation. That occurred in the mid 80s, and then ISO came about. The International Standards Organization came about in the late 80s, and that was European, that was Asian, and that was American, setting standards. And they had 9,000. Now they have 10,000. Now they have 12,000. So they have quite a bit of standards listed for pretty much everything from how thick a washcloth should be to what's the colors on a particular monitor what's the range of tolerance of colors. And then also, if you can hit those standards, you can get certified. There's a project called Reengineering that was in the late 90s. Benchmarking, that was a fairly um, popular when I was going to school, when I was your guys' age, in the late 80s, early 90s. Um, it's essentially what they do is you probably have heard this. It's called best in class, and what they do is they would benchmark to a company who they thought was doing a really good job, and then they would benchmark they would use that as the as the goal, and then they would base their standards compared to that goal. The problem we had with that was that you depending on who you benchmark to, you could benchmark to someone low, you could benchmark to someone high, or you could benchmark to the average. And what Crosby said about this was that you can always find someone uglier than yourself. So this was when I hear this, I kind of cringe because I don't know what company they're benchmarking to, and it's just from my understanding and research and business and such, that it's not good for us to really to benchmark to a company in our industry, because they might have a different demographic, a whole different range of doing business than what we have. It's good to, if you want to benchmark, say if you want to benchmark to Apple, or if you want to benchmark to Amazon or Google or DoorDash or something like that, someone who's doing a really good job in an area that you want to get to. Say if you are in a printer and you want to get into logistics, it's a good idea to benchmark to a company who's doing really good in logistics. But it's kind of frowned upon now to really benchmark to yourselves to a company in your own industry. A balanced scorecard, a management concept that helps managers at all levels monitor results in their key areas, kind of fell by the wayside. And then the Malcolm Baldrige National Equality Award that came out of the late '80s. We'll go over that a little bit. An award that specifically goes after North American businesses who exhibit Lean Six Sigma qualities, and they get a reward. And then Six Sigma came about in the late '80s, early in the mid '90s. And what that does is, we'll see the definition. This is that near perfection, and then the lean manufacturing came about. From the TPS which is eventually embraced by American businesses. And then what we have now, from the early 2000s to now, is that we're combining the best of both worlds of Lean and Six Sigma, because together they just are a really good catch-all as far as managing for quality. So again, why Six Sigma? Well, it's appropriate for every business and function. It combines many quality management systems into one, provides tools, aids, and skills. So everything that we went through in class so far, those are all been total quality tools or Lean Six Sigma tools. Provides fact-based decision-making and breakthrough thinking. It's a hierarchy of known competencies in training modules. So you kind of like have a whole workbook as far as how to do a Lean Six Sigma project. By doing a Lean Six Sigma project, it's not like you're making up the whole way of doing things. There is a hierarchy and there's a way of doing it. It's measurable and it's quantifiable. You cannot just say that you are a Six Sigma company. You have to be able to prove it. Okay. So the goals of Lean Six Sigma are: one, for continuous improvement. That's the Kaizen effect from Lean. To improve customer satisfaction, gain process knowledge, reduce defects, improve yields, increase operating income, target standards, improve process capability, constant measurement, beat the competition, and gain market share. And all of that requires a breakthrough. And then the Six Sigma objectives are directly and quantifiably connected to the objectives of the business. So obviously, you're not going to be doing some kind of objective for a flexo shop that that uh, is those objectives worked for or were chosen for Ford. So where the flexo has its own unique objectives that it wants to achieve, and so we got to have these objectives that are quantifiably and directly connected to the business. So the principles of Six Sigma. First of all, we need to have management support, and you'll see this in the handout there in the Ford, that the vision to do Six Sigma has to come from the very top. And I've sat in these places, for Lean Six Sigma show or conferences and stuff, and every time you see someone says, well, I was battling management on this, like these big companies, if they don't have the upper management does not provide the means to do what it was required to do in Lean Six Sigma, it's never going to succeed because it requires a lot of barriers, to break down of barriers. It takes a lot of devotion to the cause, and you got to spend some money in order to do it. So it requires management support from the very top, embracing customers, delivering and anticipating what the customer wants, and then delivering what they call the stealth factory, and really showing what it costs us to do things wrong. And this is that Crosby's principle of the complete transaction rating, of basically putting out there what is the cost of us doing things wrong. What we've been going through over the last couple of weeks here is exposing the vital few from the useful many, finding out what are the critical to quality and what are the critical to processes, and focusing on those and making sure we hit those. That is one of the principles of Lean Six Sigma. And then empowering people to improve the process, empowering people, employees, stakeholders, and all such to improve the process. We're not just using the people as cogs to the machine. And then harnessing the data to drive business decisions. And then a lot of times the companies get focused just on data, and if they follow just on metrics alone, they can get balled up in the data. But we're trying to harness and manage the data to drive business decisions. And as Jack Welch said in a video, it's online there, that it's, that if you just go by profit loss statements alone, you're not really managing for quality, because you could be laying off, 1,500 people in order to raise up your profit loss statement. But then what kind of value does that do? What are you imparting on value? So we're doing a real intentional look here as far as how we are managing for quality in the human level as well as in the business level. So a typical implementation. So what happens when we do a Lean Six Sigma project? So everyone is brought together. They learn the basics of Lean Six Sigma. And then the managers and the supervisors become champions. I'll give you a definition of that a little bit later. And then we have these people who are highly technical and highly competent. These are called the black belts. And these help the organizations and managers lead the projects, and they've got people underneath them. And those people underneath them are called green belts. And they're utilized to help the black belts. I know it's kind of funny because it's uses like the karate competency level, but it's a good example of a level of a competency. So the green belts are basically the people on the floor. They're the people who are actually controlling the process as well. And then the black belts are the people over them, kind of overseeing the project. And then we have the managers and supervisors, which are called champions. Underneath the green belts, there is a level called a yellow belt, and if you pass this course successfully and you can prove that you have the competencies, what I'm teaching you now is really at the lower end of the green belt level. But you will definitely graduate from this course with a competency in yellow belt if you understand just the basic concepts of what we've been through so far. And what's cool about that is that you assist the green belts in project completion, and then you would graduate to a green belt, then eventually to a black belt as you've got more data and more knowledge. And the green belts, they work with the black belts, and they're the people who know everything about Lean Six Sigma, how to do the process, how to do all the tools, but they haven't had enough knowledge or experience yet on actually managing a project. And then the black belts are the people who actually proven that they've actually managed a project that yielded $250,000 in savings or opportunities and such. And then they have a full knowledge of all the tools and the team skills. And then on top of those guys is a master black belt, and those are like the Yodas, if you will, or the senseis. Their experienced black belt has had led a lot of teams to complete projects. And what they do is they coach and train other Six Sigma team members. So in an organization, say if you're going to work for R. O'Donnelly, you might have, they might have, 30,000 employees. They might have 1,500 green belts, and they might have, 100 master black belts, and then they might have, 4,000 yellow belts. So, and those are all people who have to take the training like you've done here for the last 10 weeks. And it's an intense training. It's usually like a week or a solid week or a solid 2 weeks, just 8 hours a day, just doing the stuff that we did. So it's pretty, intense. And then they have to test out. They have to actually take a test in order to prove that they know the competencies. So the champion, like I said, the supervisors and the bosses, they don't necessarily have to have like 100% knowledge of the Lean Six Sigma as a green belt or as a black belt. But what they do though is they have to be able to assist the team in order to remove barriers. So which means, hey, you know what, we got to buy a new spectrophotometer. That supervisor, that person can actually make that happen. Or we need to have, an extra, we need another day of training. They can sign the purchase order, fund that project, fund that training. So they're really called the deployment champions because they really, they laying the road down for the team to follow. And they're rated on the success of the program. They have a budget and they remove obstacles. The sponsor, the project champion, the process owner. So this is the person who you'd be working underneath. So if you are working, say if you're doing process control, you might be working with the production manager who knows about Lean Six Sigma, who could possibly even be a black belt. And they provide support, and then they have the people resources, and they can get you into interviews, and they can get you what you need to do to complete the project with data and all that sort of a thing. So you can see, if you haven't seen it so far, that it's a team effort. There's no solo projects in Lean Six Sigma. It's really based on team efforts. So when do you call on a black belt? So after we do a process map, it is indicated that a process has high scrap, has high rework, or is significantly affecting customer satisfaction and or net profit. The project needs to be resolved within 2 to 6 months. The quantifiable project objectives and goals tied to corporate goals, and then there's not a clear, reasonable solution apparent. So there should be a possibility of substantial savings of at least $175,000 for black belt projects, and they should be run between 2 and 4 months. Huge projects should be broken down into smaller chunks. The project has to have tangible goals and objectives, and we do not call in a black belt if there's not a clear solution. The black belts should not be used to justify proposed solutions. What we should do is, we should have, when we bring the black belt on there, it's just like I'm giving you guys. You guys are defining the problem. You guys are coming up with um, uh, the hypothesis and all that in order to do your A3. I'm not presenting you the solution. You guys are coming in on your own. And then my goal, I am a black belt, by the way. I don't know if you didn't know that or not. I'm a certified black belt on Lean Six Sigma. That my goal right now is just to see you through the process, so you don't go through the pitfalls and stuff that can happen when people try to go through an A3 project. Okay, so we've talked about the MAC, but let's just really kind of look at it as far as how this is like the engine of Lean Six Sigma. First, we have define. You define the problems in the process. You measure performance. You analyze the causes of the problems. You improve the process. By doing that, removing variations and non-value-added activities. You control process so problems do not reoccur. So on the define, we went over the SIPOC. The SIPOC, is a good way for us to define the problem. We use flow charts to map out the existing process before improvements, remember the actual states. We define the problems that we really have to fix, which is the critical to the quality and the critical to the process. And then we find out what are those requirements and what are we doing in meeting them. And what are the failures in the process? We haven't really talked about the FEMA. We went over it in a lecture, recorded lecture, but it's a good tool for us to find out as far as what are the failures in the process. So an application, what would we do in the DMAIC? So first of all, we map the process as it is, find the delays and non-value activities in the process, which you guys know how to do now. We do the fishbone to find out, what is the potential root cause of a problem, and that's examining the architecture of the processes. And then we're going to talk about this a little bit later on solution engineering. But we have a problem state and we have this solution state. So when we're in a problem state, we got to, we can't just be stuck in the problem. We have to have our eyes focused on the solution state, which we'll go over a bit later. But the problem is a situation that requires action in which the action is not immediately apparent. So it's a good definition of what a problem is. A situation that requires action in which the action is not immediately apparent. And what happens is that we often get fixated on the problem and forget what the process resembled before the problem occurred. Many problems can be fixed at the define or measure stage without having to go to the rest of the phases. This is kind of anti-thema to a lot of people who teach Lean Six Sigma, but I found out this case is that if we have the methodology ingrained in our head about define, measure, analyze, improve, and control, it doesn't matter if it's in your personal life or if it's just, whatever it is, your car doesn't start, do the DMAIC on that. A lot of the times, the problems can, immediately once they're defined, you measure it and then you do something to fix it. So, this is not what I'm talking. I'm not talking about a DMAIC process or an A3 process. I'm just talking about just general run-of-the-mill, 98% of all the problems we have or something that could be resolved, in a few minutes. Okay, so we tackle the harder problems after the easiest to fix problems. So remember, this is going after the low-hanging fruit. So once you have identified, hey, we can make these quick changes and have a benefit, obviously you're going to want to make those changes first. And then you're also going to triage and prioritize, that's the problems as they come in. And, it's like, this is areas that we have to do. This is business imperative, or this is what we want to do, the needs from the wants. There is a razor, Occam's razor, which I don't know if you've heard this before, but it's great for this going into creative engineering. It's the simplest solution is often the correct solution. So as problem solvings, we always got to keep in mind the Occam's razor, right? what do they look at first for when someone gets, someone gets killed, or murdered? They look after the person, who they know, the spouse or whatever. So, most of those happen. Most of those occasions occur with the simplest solutions, often the correct solution. And then as we go harder, as we go higher up into our sigmas, from a 5 sigma to trying to go into a 6 sigma, the problems get a lot harder, exponentially get harder to solve. In the measure phase, after we define one or more of the critical output characteristics, we can start using the house of quality. We can use the breakthrough formula. We can evaluate what metrics to use. We can assign levels of process capability, and those are the CPCPKs. We can determine what sigma levels we're at and where we want to be. And then here is what we're trying to do is we're trying to quantify what the problem is in the measure stage. So quantify the problem. And as we talked about on Monday, we're using Goodhart's law here. We do not want to just rely on one metric. We want to use the dashboard metrics and to look at metrics across the board. They help tell a different story. Again, like the yield metrics take into account rework and scrap, well, CPK and CP don't. So we want to look at, we don't want to just be balled up into one type of metric. We want to have a bunch of metrics. We want to make sure we use the appropriate sample size, homogeneous, and making sure that the data collection and process control exercises are part of our job, not elective. And then process control for printing systems is not an exact science. This is what my experience, and for us, we have to come up with a system that monitors stability and that works for us and our processes, especially for those of us who are going into flexo and packaging and wide format and such, and inkjet. It's the crux of new technology that's coming out there that will require us to revamp how we determine what is process stability. Analyze, that we're looking at the process analysis we're figuring out what the cost of poor quality is, the rework time, etc. We're doing root cause analysis, doing the cause effect analysis, the proto charts, the fishbone diagrams, and the control charts will solve 90% of the common problems with defects. So if we just learn those 3 things, 90% of the common problems with defects can be resolved. Proto charts, fishbone, and the control charts. In application on that phase, the main output of this phase is to come up with a hypothesis, what is causing the problems, what needs to be improved. So the hypothesis just says, if I do X, then Y will happen. And then when testing our hypothesis, we only change one factor at a time, then test it while keeping all the other conditions the same. Now, this is harder to do than obviously than it looks. Like, say if you have a lot of low-hanging fruit, you might want to do the low-hanging fruit first, test it, and then go back and do the harder changes in order to get to the 40%. So obviously, we do not want to just not improve with the low-hanging fruit. So you've got 6 or 7 things you want to do. You're not going to just do one small change and then test it. So you're just gonna have to use your own methodology on here as far as what is it you want to do. Basically, what you want though is after the process has been changed, you want to be able to, when you do a test, you want to make sure that you can prove that whatever you changed had the desirable effect. That's essentially what you're trying to do. Different for us. We're not trying to. We're not in the field where we have to measure the gap between 2 parts and such. We're talking about the creatives here. So again, we would come up with our own way of doing this in problem solving. And if the test is successful, then you want to repeat, do the scientific method just to make sure it was a correct solution. For those of us who are going into the technical, the fields of, server management or whatever, equipment management, we would want to do this for sure. We would want to do the one part, test it, and then determine if what we did had the desirable effect. And then the last, I think it's next week, we're going to go over using probability as a tool. Probability is huge in Lean Six Sigma. You know, they have an aim of 95% confidence in our answer in order to move on and perform the actions required of us. So if we have a 95% confidence that what we're going to do is going to have an effect or whatever, then we would go ahead and perform that. We wouldn't do it if we didn't have that 95%. So where do we get those 95%? Well, we looked at we're going to be looking at the scatter plot next week for probability, and also, a bunch of other metrics that we can use in order to determine, what is our where are we at right now, and as far as the use of metrics, the FTYs and the RTYs and such, in order that gives us an actual percentage. In the improvement stage, I'm actually devoted the last lecture of the quarter for an improvement in opportunities, because it's so important, because it's really like the meat and potatoes of what we're trying to learn. It's like, well, what do we do in order to improve our process? What we're trying to do is we're not trying to, we have to firefight, we have to fix problems as they arise, but we're not improving the process if we're just firefighting, right? And remember this special cause variation, we're just bringing the process back to stability. What we're trying to do is we're trying to bring that common cause variation down, trying to tighten up the tolerances so we can, increase our value to the customer. Improvement means you are controlling and reducing common cause, the normal variation in the process. So the goal of the process mapping is to identify and eliminate the hidden costs that do not add value. And the value added is any activity or process that's essential to deliver the service or product to the customer. There is in business non-value addeds that are required by the business to execute value added work, but really add no value from a customer standpoint. Order entry, processing, purchasing, sales, marketing, and all that sort of thing. Those things are required for the business, but we can't necessarily call those to be, non-value added that we can eliminate. Now, what we're trying to do, obviously, we're trying to get the non-value added waste. They add no value from the customer's perspective and not required for financial, legal, or other business reasons. So those are the waste that we're trying to get rid of. When we're going after improvements, we need to go over after improvement projects that reduce variation, eliminate defects in the process, eliminate scrap and rework, improve customer satisfaction, reduce lead time, which is the turnaround, the voice of the customer, reduce production costs and improve performance, and reduce cycle time, or however long a product remains in shop. So when we're looking at improvement projects, we just go over and can see, okay, well, if any of these 6 things are occurring, those are good candidates for an actual DMAIC or A3 project. And as I was saying before, and the improvements or opportunity projects in Lean Six Sigma, they're done with teams and not individuals. And improvement projects should save money, not just rescue a job from disaster. So that is, again, that's not the firefighting. We don't just do an A3 or DMAIC in order to save a job from disaster or firefight or crisis management. These are our intentional projects that are made to improve the process. And then on the control phase, you sustain the improvement efforts made in the improvement phase, and then we develop voice of the process and voice of the customer limits are established and maintained. It's very important for us to actually develop standards on the control phase, because that's how we are going to measure the whole process. So say like if you're in the UX UI and you're designing an app, and then you're going through this whole DMAIC in order to design the app, you release it, and it's working. And then what you would do is you'd use the customer data and the voice of the process data in order to come up with benchmarks as far as, okay, this is where we go, can't go any further. That's where we get the voice of the customer limits, the specification limits. and we get the voice of the process limits, which the voice of the process really tells us, what we can expect the process to operate in under a stable condition. And then tools for these phases, just basically the control charts, the process capability studies, the DPOs, DPMOs, the FEMA, and the CTR. Now, there is another process there for those. So the DMAIC is a good process to do when something's existing. So there is something called a DMAIV, which is what you might do. It's a slightly different methodology when it's a new process. So define project goals, measure and determine customer needs, analyze process options, design process to meet customer needs, and verify the design performance and ability to meet customers' needs. This is quite a bit like Duran's trilogy. So the DMAIV is used for a new process or a new product development. So what's the difference between the two? Well, the DMAIC, we use it when a product or a process is in existence. It's not meeting customer specifications, or it's not performing adequately. And when we use the DMAIV, is when a product or process does not exist and needs to be developed, or when a project is so bad and it's been trying to improve and it has still not been optimized in meeting customer specifications, then you would basically redesign the process and go into the DMAIV. And of course, when we're doing the reporting out, we're using a DMAIC, but we're using the A3 methodology in order to report out. And you've seen that. This is my A3 that I did for one of my black belt projects. It's just with invoicing system for external customers. It's port 1. You can see I've got current state, ideal state. I've got the fish bones. I've got the targets, and then I've got the control phase as far as using a check sheet. The part 2 of this process was a little bit more involved. This is for internal customers. And you can see here this has Pareto's, and you can see on a black belt project, you're using all 7 tools or even more. On the green belt process, you might only be using 4. And like where we're doing at the yellow belt process, we're doing 2 or 3. So at the end of this quarter, you'll be able to you'll be able to look at your branding or whatever that you're trying to do, what if you're doing a process improvement, and you will be able to use the methodology that we discussed in our DMAIC.